Okay, class, we're about to start section 4.3, multiplying, dividing fractions. Section A, multiplying fractions. Rosie decided that she was going to devote 1/3 of her yard to a flower garden. She then planted 2/5 of her garden with some beautiful pink Gerber daisies that she found. What portion of her yard is planted with Gerber daisies? Okay, now notice that the product turned out as we might have expected, 1/3 times 2/5. Now, if you look here, this has been converted to this multiplication of fractions. 1 times 2 is 2, 3 times 5 is 15. So if you look here, we could count up 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That would be our denominator, the whole. Now we have 2 of Gerber daisies. So that would be 2 out of 15, which would be our final answer. Okay, the rule for multiplying fractions is multiply the numerator by the numerator, or the top times top, which we did here. Multiply the denominator by the denominator, bottom times bottom. 3 times 5 is 15. And then simplify if possible. 2 and 15 have nothing in common but 1, so it's simplified. Now, I want to do a few examples of multiplying fractions. So let's start off like we just learned. We multiply top times top, 3 times 5 is 15. And the bottom times the bottom, 7 times 6 is 42. Now in our previous lesson in 4.2, we simplified using the greatest common factor. The greatest common factor of 15 and 42 is 3. 15 divided by 3 is 5. 42 divided by 3 is 14. So this is our final answer. Now, number 2, we multiply straight across. 7 times 2 is 14, and 9 times 3 is 27. Now, if we look at 14 and 27, they have nothing in common except 1. So that is your final answer. Now, multiply number 3. 4 times 3 is 12. And 9 times 10 is 90. Now we look here. We had 12 and 90. The greatest common factor of 12 and 90 is 6. 12 divided by 6 is 2. And 90 divided by 6 is 15. And this is our final answer. Now we come here to number 4. Now first of all, we notice we have a negative times a positive, which is negative. Now we multiply straight across. 8 times 3 is 24. And 15 times 16 is 240. Now the greatest common factor of 24 and 240 is 24. Now a negative 24 divided by a positive 24, we know that will give us -1, because a negative divided by a positive, we know will give us negative. 24 divided by 24, I know this mark came up here, so we know this is supposed to be a 24. 240 divided by 24 will leave us 10. So our final answer here is a -1/10. Now we scroll down here to number 5. We have a negative times a negative, which we know is positive. And we multiply straight across. 5 times 9 is 45. And 6 times 14 is 84. Now we look here, 45 and 84. The greatest common factor that 45 and 84 has in common is 3. 45 divided by 3 is 15. And 84 divided by 3 is 28. And that is your final answer. Now we come to number 6. Number 6 is a little different than what we've covered here so far, because we have a whole number multiplied by a fraction. So the first thing we should do, let's change this whole number to a fraction. We'll make this 6 over 1 times 3 over 8. You could always put a 1 under a whole number, or I should say an integer. Now, we can multiply straight across. 6 times 3 is 18, and 1 times 8 is 8. Now we can simplify this. 18 and 8, the greatest common factor that 18 and 8 have in common is 2. 18 divided by 2 is 9, and 8 divided by 2 is 4. So our final answer is 9/4. Now I know this looks a little odd because this is an improper fraction, but changing it to a mixed number is not simplifying. Simplifying just means that the only thing that could go into your numerator and denominator is 1. And that's what we have. Okay, now we look at number 7. Now this time we have the introduction of variables here. So we still solve this the same way. We still multiply the numerator times the numerator. 7x times 5 will give us 35, and we'll bring over our x. Now our denominator, 10 times 8x squared, 10 times 8 we know is 80, and we'll bring our x squared. Now we need to find the greatest common factor. Now this is what we would do here. First, let's deal with the number here. 35 and 80. The greatest common factor they have is 5. Now with the variables, this is what you would do. You would look and see if they both have the same variable. The numerator and denominator both have an x. Now what you want to do, the greatest common factor is always the variable that has the lowest exponent. This does not show an exponent, but we know this is assumed to be 1. So we'll divide both of them by x. So now, 35 divided by 5 is 7. 80 divided by 5 is 16. Now we deal with the variables. X divided by x we know is 1. We don't have to write the 1 here because we have 7. Now x squared divided by x, we know x squared divided by x would just be x. So it'll be 7 over 16x. Now we come here to number 8. We'll multiply. 4 times 5w to the 5th will give us 20w to the 5th. All over, we add 25w cubed times 6. 25 times 6 is 150. And we will have w to the 3rd. Now, 20 and 150, they both have, the greatest common factor they have is 10. So now, this is what I want to do. Before we divide out the greatest common factor here, I want to show you another method of doing the variable first. Let's expand these variables here before we simplify out the greatest common factor. We add w to the 5th, which means w times itself 5 times. And then in our denominator, we add w to the 3rd. That means w times itself 3 times. So we can simplify out all the w's we have in common. If you notice here, we had 3 sets of w's in common. So we simplified that out. So this is the same as 20 w squared all over 150. Now, we're done with the variable here, but we still need to simplify out the greatest common factor of 20 and 150, which happens to be 10. We divide both by 10. 20 divided by 10 is 2, and we'll bring over our w squared. And 150 divided by 10 is 15. So this here is our final answer. Now we come to section B, evaluating exponents on a fractional base. Now if you notice here, we have this fraction in the parenthesis, and we have 2/5. Now remember in our order of operation, we always do what's in parentheses first, even before we get to this exponent. 2 and 5, they have nothing in common, so this will remain 2/5. Now we have to take this parenthesis to the 3rd power. So this would be 2/5 times 2/5 times 2/5. Now we can multiply this just like we did any other fraction. We'll multiply all the numerators, or the tops. 2 times 2 is 4, times 2 is 8. And then we'll multiply our denominators, or the bottoms. 5 times 5 is 25, times 5 is 125. And they have nothing in common, so this is your final answer. Now we come here to number 2. It's the same setup. 3 and 8, they have nothing in common. They're in parentheses, so we need to see if we can simplify that first. And now we can rewrite this. This would be a negative 3/8 times a negative 3/8, because this is taken to the second power. A negative times a negative is positive. 3 times 3 is 9, and 8 times 8 is 64. So this is our final answer. Now we come here to number 3. We add 2 to the third power over 5. Now this is not in parentheses, but the only thing taken to the exponent is the 2. So we need to do that first. 2 to the third power is 2 times 2 times 2. All over 5. 2 times 2 times 2 would give us 8 over 5. And we know 8 and 5 has nothing in common, so this is our final answer. Now we come here to number 4. We have negative 3 to the second power over 8. So now, the first thing we should do is this exponent. Remember, the only thing that's taken to the second power is this 3, not the negative sign. So this will give us negative 9 all over 8. Now, negative 9 and 8 has nothing in common, so this is our final answer. Now we scroll down here, dividing fractions. The rule for dividing fractions is we would take the reciprocal or flip the second fraction and multiply. So now, if we look here, it says, why does this work? Let's try it out on a simple problem. 6 divided by 1/2. Think about a physical model. Suppose that you had 6 candy bars and you were going to give half to each of your friends. How many people could you share with? So we know that would give us 2, 4, 6, 8, 10, 12. That would give us 12 people we could share with from the 6 candy bars that we broke in half. Now, if you're smart, instead of counting the little chunks of chocolate, you would say, I'm getting 2 pieces for each of the 6 chocolate bars. So that is 6 times 2 is 12 pieces of chocolate. So I could share with 12 friends. Now we're going to look at this in terms of mathematical terms. It says, think about how the division rule for fraction would tell us how to do the problem. We changed that 6 to make it 6 over 1, so it would be a fraction. So we would keep the first fraction the same, division would become multiplication, and we'd take the reciprocal or flip the second fraction, which would be 2 over 1. Now we multiply straight across. 6 times 2 is 12, and 1 times 1 is 1. And we know 12 divided by 1 is 12. So that is our final answer. Now we come down here to example 1. We keep the first fraction the same, 2/5. Division becomes multiplication, and we take the reciprocal of the second fraction or flip it. Now we multiply straight across. 2 times 7 is 14, and 5 times 4 is 20. Now we know 14 and 20, the greatest common factor is 2. We divide both by 2, and that will give us 7/10. Now we come here to number 2. Now we have negative 33 divided by a negative 6 over 11. Now we know a negative divided by a negative is positive, so we don't have to worry about the negative sign anymore. But let's rewrite this. This will be 33 over 1 divided by 6 over 11. As a matter of fact, I'm just going to add the negative sign here just to leave it the same. Okay, now again, a negative divided by a negative, we know it's positive. So we'll keep the first fraction the same. Division will become multiplication, and we'll take the reciprocal of the second fraction. Now we multiply. 33 times 11 is 363, and 1 times 6 is 6. The greatest common factor that they have in common is 3. So we divide the numerator and denominator by 3. 363 divided by 3 will give you 121. And 6 divided by 3 is 2. And they have nothing else in common, so this is your final answer.